All right, this is the video on section 5.6. This is our last section of notes for the day that we're missing on Monday, the week of Thanksgiving. And we're going to talk through these notes and teach you one other way to find the area under a curve, especially this is a useful rule if you cannot find the antiderivative. So in section 5.4, we learned that we can use the fundamental theorem of calculus to evaluate a definite integral if we can find that antiderivative of the integral or the integrand. If we cannot find the antiderivative, we can approximate the area using something we're going to teach you called the midpoint rule. But before we teach you that, we're going to show you how to do one where we don't know the midpoint rule essentially yet, but we're going to look at finding the area under the curve by making 4 rectangles. And I'm going to draw this graph pretty big because I want to be able to see what I'm drawing. So we're going to zoom this in. 2, 3, 4, 5, 1, 2, 3, 4. Okay, so this is going to be 0, 1, and 2 because I know I'm going from 0 to 2. So I'm leaving this as now a half, and this is 3 over 2. And the reason I'm breaking it up like this is because from 0 to 2 is my boundary for this. But I wanted to use 4 rectangles, so that means I probably need to go every half. And that's one of the things we'll teach you how to find in just a second is how do I know that I needed to go every half. And then I'm going to need to know about this graph. So I'm going to do a little XY chart and plug in 0, 1, and 2. Those are the points they typically would want us to find. But we can also find a half and 3 halves if we wanted, but this should be sufficient. So 0 squared plus 1 is 1. 1 squared plus 1 is going to be 2. 2 squared is 4 plus 1 is 5. So this is just going to be counting by the normal amounts. So this would be 0, 1, 1, 2, 2, 5. That's a parabola. Oops. Hard to draw on the computer, but we'll get it fixed. And we're saying that if we draw the x equals 0 line, which is this one, x equals 2, which is a vertical line through 2, the x-axis, and the curve of that graph, we're looking for the area in that region. Now, what they told us to do was to use 4 rectangles to approximate it. So notice I brought my I broke this up into 4 subregions using the fact that I could get 4 rectangles if I go by a half. And then I'm going to draw from here up. And usually I don't go all the way up. I try to, the rectangles are kind of hard to see. I try to make sure the top of my rectangle would go through the actual curve, because you want it to actually touch it. So this is the actual rectangle that I drew here. So see, it doesn't actually go all the way to the top. And then for my next one, I would find kind of the middle between those, and I would draw a rectangle and at the best height that you can. I know I'm not drawing really straight lines. So notice part of it's above and part of it's below. That kind of equals out because this is a curve. So I've got this rectangle right here. I'm going to do another one. So this time I kind of find the middle of this. So we're kind of using that midpoint rule without defining it yet. And then we're going to draw the highlighted area. Get that extra little piece right there. And then we have one more. So find kind of the middle between the 2 x values on the graph. Go up, across, and there. So I notice I left a big part here that's not covered, but that's supposed to kind of equal out with this. I know it's not exact or perfect. But what the rule is that if we added up all these rectangles, because there's overlap and underlap in certain places, it would be roughly equal to the area. So it would be an approximation. So the way we figure this out is you kind of estimate where you think this height is right here. So for us, we would have to know what's halfway between 0 and a half. And we can actually, instead of just estimating, we could figure this out. So if you find out what f of 1/4 is, you'll know this height right here. A rectangle is a length times a height, or a length times width if you want to think of it that way. So we know the length is 1/2. If we can figure out how high up this goes, then we'll know the width and we can multiply to get the area. So if we do f of 1/4, that would be 1/4 squared plus 1. That's going to be 1/16 plus 1. Think of that being 16 over 16. So this is 17 over 16. So the area of my first rectangle is 1/2 for the length and 17 over 16 for the width. So that is 17 over 32. So there's my first one. So I'm going to make me a little list of all my areas. Okay, let's find the second one. So we would want to find the height of this rectangle, which actually ends up being halfway. So that is f of 3/4 is what we're going to want to find to figure out the length of this. And this is still 1/2 for the dimension down here. So f of 3/4 is 3/4 squared plus 1, which is 9/16. I already know 1 is 16 over 16. So this is 25 over 16. So area of the second rectangle is 25 over 16 times 1/2. So that's going to be 25 over 32. Okay. All right, for the next one, we're going to be at, this would be 1 1/4, so that's going to be 5/4. So we need to know f of 5/4 to figure out this one. And I figured that out because it's 1 1/4. So that's 4 times 1 plus 1, which would be 5/4. So f of 5/4 is 5/4 squared plus 1, which is 25 over 16 plus another 16 over 16. That is going to be 41 over 16. So area of the third triangle, since all of these are a half away from each other, it's still going to be 1/2 times the 41 over 16, or 41 over 32. All right, and then we need to do one more, and then we will have completed this midpoint method without even teaching you really what it is yet. We've kind of just talked through it. So this one would be, that's 3/2, which would be 6 over 4 if you went back to being fourths. So this one right here is 7/4. So f of 7/4 is 49 over 16 if we square it, plus 16 over 16, because that was my x squared plus 1. This would be 15, carry the 1, so that's going to be 65 over 16. So my area of my fourth rectangle is 1/2 times 65 over 16, which is going to be 65 over 32. If you add all of those up, that's going to give you an approximation for the area of the actual curve. So this is, let's get our calculator out. It's 17 plus 25 plus 41 plus 65, which is 148, divided by the common denominator of 32. It's 4.625. So we think that the area of this is approximately 4.625 using this midpoint rectangle method. Now, the good thing is x squared plus 1 was much easier to find the area by just doing the actual integral. So we want to show you that this midpoint rule actually does work. It gets you pretty close to the correct area, so that if you did have a function that was not able to find its antiderivative, then you could use this midpoint rule to find the actual approximation. So remember, to find the area under a curve, you do the definite integral, 0 to 2, of the function. We take the antiderivative of both parts, so that's going to be x cubed over 3 plus x. And then last time we learned that to find the area, we evaluated at the first one on top, the upper limit, minus the bottom one. So this would be 2 cubed over 3 plus 2 minus 0 cubed over 3 plus 0. That is 8 over 3 plus 2 minus 0 minus 0. So this is 8 over 3 plus 6 over 3. That's 14 over 3. Now I know that's not the same fraction we got here, but when you divide it, notice it comes out to 4.6 repeating, which is pretty close to where we got by using the midpoint rule. So it's going to be off a little bit, but it is still a way to find the area under a curve. So we're going to practice doing some more, but we're going to give you the official guidelines of the midpoint rule. So it says to approximate the definite integral from a to b of f of x dx using the midpoint rule, here are the steps you should follow. So you don't just make up points. I was kind of leading you in the correct direction, but we need to have a set rule of how to find those intervals. So you have your closed interval a to b, and they're going to tell you to divide it into n subintervals, like 4 rectangles or 3 rectangles. Each would have a width of delta x. Delta x is always found by subtracting the higher of the 2 endpoints, b, minus the lower one, and then dividing by the number of rectangles you want. That tells you how your width of your bottom of your rectangle should be. To find the midpoint of each subinterval, you can either, if you know it automatically, if you know what the middle is, you can just write it down. But if not, you can add the 2 x values around it together and then cut them in half. And then evaluate each each midpoint at f, and then add them all together and times it by this sum. So this sum right here is all those different heights, and we just times it by the width once. So we kind of take care of the multiplication of the width times the length, the width times the length, width times length. They do that all in one step here. So it's going to be the delta x from step 1 times the sum of all these midpoint heights once we plug them into f. So let's try example 3 and see what we get. So we have midpoint rule of n equals 4 to approximate the area, that's supposed to say area, of the region below f of x equals 9 over x on 1 to 5. So the first thing you're going to do is going to find that delta x. So you take your upper limit minus your lower limit and you divide it by the number of rectangles. So this is 4 over 4, which is 1. So each rectangle has length or width, whichever way you want to call it, of 1. Okay, so then I go to drawing my graph. So I'm going to have from 1 to 5. So 1, 2, 3, 4, 5. I don't need any other points in between yet because this is the exact length. So if you're going from 1 to 5 with a length of 1, each rectangle is just going to end up taking up one of those pieces. Okay, and then our next step is going to be to find the midpoints of each of those so that we know how to draw our triangle. So if you think about it, these are all going to be over a half because these are just integers, so halfway is going to be on the halves. So the first one is you find it by adding 1 and 2 together and then dividing by 2. That's how you find a midpoint. So 1 plus 2 is 3, divided by 2 is 3 halves. 2 plus 3 is 5, divided by 2 is going to be 5 halves. 3 plus 4 is 7, divided by 2 is 7 halves. And 4 plus 5 is 9, divided by 2 is 9 halves. So those are going to be my midpoints. Okay, and then I'm going to figure out what the graph looks like, because you do need to know that. So this is going, well, I do this anyways. You don't have to do the graph, but I find that it's more useful. So we need to look at, I just like to draw it in, but like I said, you don't have to. I'm going to do 1 to 5 just to give us an idea of what this would have looked like. 4, 5. So this would be 9 over 1 is 9, 9 over 2 is 9 halves or 4.5, 9 over 3 is 3, 9 over 4 is 9 fourths, and 9 over 5, which we can get decimals for both of those. But again, because we know the midpoint formula now, we don't have to do this part of the graph, but I always do it on another one just to make sure you see what we're doing. 1.8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 9. 2 is at 4.5. 3 is at 3. 4 is at 2.25. And 5, which I didn't do that at 4, sorry, there's 4. And 5 is at 1.8. So just remember what this midpoint rule is doing for us. We're finding the area under this curve. Okay, and remember that each rectangle we draw, oops, the midpoint right here is the height that we're looking for. Yeah, I'm going to stop drawing the picture because I'm really bad at it on this thing. So all we're doing to evaluate this is remember delta x times the f of the x1, which is this first midpoint, plus the f of the x2, which is the second midpoint, plus f of x3, which is the third midpoint, plus f of x4, which is the fourth midpoint. And the number of x's you should have inside here, inside your function, is the number of subintervals they told you to do. So remember our delta x is 1, so we're going to have to evaluate f of 3 halves plus f of 5 halves plus f of 7 halves plus f of 9 halves. Okay, so our function was 9 over x. So 9 over 3 halves, you'd multiply top and bottom by 2/3. So that's going to be 9 over 1 times 2/3, which is going to be 6. So this first one is a 6. 9 over 5 halves would be 9 times 2/5. So that's going to be 18 over 5. 9 over 7 halves would be 9 times 2/7, which is going to be 18 over 7. And 9 over 9 halves would be 9 times 2/9, which is just going to be 2. So we can get a decimal for these, so you don't have to go crazy with getting a common denominator. So I'm going to be doing, I go ahead and do my fractions first. 18 divided by 7 plus parentheses 18 divided by 5. So I've got both my fractions, plus 2 plus 6. And then once you've got them all, you times it by 1, or whatever the delta x is, which in our case is 1. And we get, looks like 14.17. But let me double check myself. When we did 9 over 9 halves, that would be 9 over that. We flip that and that cancels and gives us 2. Yes, hang on just one second. I'm double checking all my numbers. All right, we're good, except I wrote the wrong number down here. It's supposed to be 14.17. That happens when I try to read and talk at the same time. So 17. So that's what we got using the midpoint rule. Okay, since this one also would have been easy to do a regular integral on, let's try to figure out the integration from 1 to 5 of 9 over x dx. We can pull the 9 out to the front, and this is 1 to 5 of 1 over x dx. And again, if you can do the definite integral, it's usually about 100 times faster than the midpoint rule. The midpoint rule is there for us when we can't take the antiderivative very easily. So this would be natural log of x. So natural log of absolute value of x from 1 to 5. So that's 9 times natural log of 5. Since it's already positive, I don't need the absolute value, minus natural log of 1, which is also already positive. Natural log of 1, though, I believe is 0, but let me double check that. Yes, so this is just going to be natural log of 5 times the 9, which comes out to about 14.48, so we were pretty close. It's not going to be exact, but we were pretty close with what we had for the midpoint rule. Okay, so we have just a couple more we want to do. We're going to use the midpoint rule on function 1 over x squared plus 1, which would be one that we could not have done the antiderivative on, because since there's an x squared down here, we would have needed a chain rule of 2x somewhere in the function. You can't just throw an x in when there's not one there. So this is going to be one that this is actually a very useful rule for us to use. So delta x is going to be, the region is from 0 to 1, so 1 minus 0 over 5 subintervals. So we are going to use a subinterval length of 1/5. So I'm not going to draw the whole graph this time. I'm just going to break the 0 to 1 up into the 1/5. So this would be 1/5, 2/5, 3/5, 4/5, and this is 5/5, which is 1. The midpoints of each of these, which is what we need to find our formula, imagine taking the two things together, adding them, and dividing by 2, which is going to make all the bottoms 10, because you're going to be doubling 5. So 0 plus 1 is 1, divided by the 2 is going to be 10 down there. 1 plus 2 is 3, so they're going to see a pattern. This is 3/10. This ends up being 5/10, or a half. This ends up being 7/10, because you add 3 and 4, and then you double the bottom. And 4 plus 5 is 9/10. Now, if you want, you can reduce 5/10 once you get it. I always list it first, then reduce it. So this one's actually a half that I'm going to plug in, 7/10 and 9/10. So remember my formula, delta x times f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5, since there's 5 subintervals this time. This is 1/5, and I'm going to use my calculator here. So let's just get decimal approximations. We can go out to 3 decimals for each of these. So this is 1 divided by parentheses, and we're going to have 1/10 squared. So 1 divided by 10 squared plus 1. Okay, that is 0.99, so 0.99. Let's do 3/10. So 1 plus parentheses, parentheses. I started too many parentheses. So 1 divided by, I should have said. Parentheses, parentheses, 3 divided by 10 squared, and then plus 1, close parentheses. That is 0.917. I'm going to go to 3 decimal places. Plus, let's do a half. So 1 divided by 1/2 squared plus 1. That is 0.8. Now we're plugging in 7/10. Squared plus 1. And that is 0.671. And the last one is 9/10. Plus 1. And I got 0.917 again. I think I typed something in wrong, because we shouldn't get the same thing on that last one again. Let me double check that one. So let's work out that very last one again. So 1 divided by parentheses, parentheses, 9 divided by 10, close parentheses, squared, plus 1 is 0.552. I knew that didn't seem quite right. Okay, so we add together all the ones we have, and then we're going to divide them by 5 since we have the 1/5 out front. So this would be 0.552 plus 0.671 plus 0.8 plus 0.917 plus 0.99, and then divided by 5. And we're getting 0.79 if we rounded 2 decimal places. So 0.79, which is pretty good since we would not have been able to find this one any other way since we don't know how to take the antiderivative of 1 over x squared plus 1 because we don't have an x in the function to be that 2x that you would need for the chain rule. So that's pretty interesting that we can actually now find that area. So let's look at, we have our last two. So this one says use the midpoint rule with an n equal to 4 to approximate the area of the region bounded by the graph f of x equals square root of x squared minus 1, the x-axis, and the lines x equals 2, x equals 4. So my delta x would be 4 minus 2 divided by the 4 subintervals, which is 2/4 or 1/2. So that means on my number line, if I start from 2 and I go to 4, I know 3 is going to be in the middle. That's going to be one of them because I'm going by halves. This would be 5/2, and this would be 7/2 because that's 2.5 and 3.5. Again, just add those together and cut it in half to get that, but that's not our midpoints yet. So our midpoints, remember, are halfway between all of our subinterval lengths. So this would be, if we add it together, it's 7, and then we double the bottom since we're dividing by 2, so that's 7/4. 5 plus 3 would be 8, double the bottom, so that's 8/4. That's not right. 5 plus 3 is 8, double the bottom, that's 8/4. But that doesn't make sense. Hang on just a second. Oh, I've got to get a common denominator first. Duh. Sorry. Brain's tired. This is 4/2 and 6/2 and 8/2. To be able to do the midpoint rule, you have to be able to add them together, which means they have to have a common denominator. So this is 9/4, not 7/4, because 4 plus 5 is 9, double the bottom for dividing by 2 is 4. Then this would be 5 plus 6 is 11/4. 6 plus 7 is 13/4, and 7 plus 8 is 15/4. Essentially, it just goes up by 2 every time on those. So my midpoints are 9/4, 11/4, 13/4, and 15/4. So my formula for my area is approximately 1/2, which is my delta x, times f of 9/4 plus f of 11/4 plus f of 13/4 plus f of 15/4. Okay, and our function is x squared minus 1 under a square root. Now, if you wanted to, you could do the formula really long and get the common denominator for each part. I'm just going to type it in on my calculator. So 9 divided by 4, then squared, minus 1, then a square root. So this first one is 2.016. Okay. Then we have 11 divided by 4, squared, minus 1, take the square root, 2.562. Then we'll have 13 divided by 4, squared, minus 1, square root, 3.092. And then 15 divided by 4, square it, minus 1, square root, 3.614. We'll add all those together, and then we're going to cut it in half because of that delta x out front. 2.016 plus 2.562 plus 3.092 plus 3.614, cut it in half, 5.642, so 5.64. All right. So let's look at our very last one. This one's an application, but it's the same thing. So it says at time t in seconds, the velocity v in feet per second of a car given by v of t equals 3 plus 0.2 t squared for 0 to 6. So notice we're on a closed interval. That means we're probably doing a definite integral. Use n equals 3. So now they've given me an n, which means that tells me we're doing the midpoint rule. We're doing the rectangles. So this would be delta x is 6 minus 0 over 3. So it's going to be a delta x of 2. So on a number line, here is 0, and then 2, because we're going by 2's, 4, and 6. So that's 3 subintervals. Then my midpoints would be 1, 3, and 5. My midpoints are nice numbers this time. So midpoints are 1, 3, and 5. So we just plug this in to remember each one for the function. So this is going to be 2 for delta x times v of 1 plus v of 3 plus v of 5. So v of 1 would be 1 squared times 0.2 is 0.2 plus 3 is 3.2. That one's not too bad. For 3, we have to square it, which is 9, times the 0.2 plus the 3, so that's 4.8. And then we have 5 squared, which is 25, times 0.2 plus 3 is 8. Add them together. Plus the 3.2, and then double it since our delta x was 2. So it's going to be 32 feet, because it did ask us to tell us the total feet that were traveled during this time, so 32 feet. So that's pretty interesting. So we found all of these things out by using the midpoint rule. It allowed us to do estimates of area under a curve, even if we couldn't take the antiderivative. So that's the end of this section. There'll be a worksheet, remember, that you're supposed to do that kind of models some of these same examples, and that will be turned in when we come back from Thanksgiving break. So have a wonderful break.